American intelligence agencies are watching. Silicon Valley CEOs are watching. Defense analysts in Washington are watching. Economic policymakers across multiple federal departments are watching. And what all of them are seeing coming out of China's humanoid robotics industry is making them genuinely, seriously worried in a way that the United States has not been worried about a Chinese technology sector in a very long time. This is not about one impressive robot demonstration from one Chinese company. It is not about a single product launch or a single viral video that grabbed attention for a week and then faded from the conversation. What is happening in China's humanoid robotics industry is something much larger, much more structural, and much more strategically consequential than any individual product. China has quietly built an entire industrial ecosystem around humanoid robotics, and multiple competing companies, deep manufacturing infrastructure, integrated supply chains, supportive government policy, and aggressive deployment timelines that has moved that country into a clear leadership position in one of the most strategically important technology categories of the entire 21st century. And the United States, the country that built Boston Dynamics, the country whose technology billionaires have been talking about humanoid robotics for years, the country that until very recently assumed it would lead in any meaningful AI and robotics race, is now scrambling to figure out how to catch up to a competitor that almost nobody in mainstream American discourse was talking about 5 years ago. Today we are breaking down what China is actually building, why it is causing this level of concern at the highest levels of the American government and technology industry, what the specific dimensions of the Chinese advantage actually are, what the military implications look like, what America is doing in response, and what the next 5 years of the global humanoid robotics race realistically look like. This is one of the most important technology stories of the decade, and almost nobody is talking about it with the seriousness it deserves. Let's get into it. So what exactly is China actually building, and how did this happen without most of the world noticing? The Chinese humanoid robotics ecosystem in 2026 is not one company or one product. It is a sprawling industrial sector with multiple major players, dozens of smaller competitors, deep supply chain integration, and a level of cross-pollination between companies, universities, and government research institutions that gives the entire sector a velocity that individual Western companies struggle to match. Unitree Robotics, based in Hangzhou, has been the most internationally visible Chinese humanoid robotics company. Their G1 humanoid robot has been demonstrated in countless videos performing complex movements with a fluidity and balance that surprised most international observers when they first encountered it. Beyond the G1, Unitree has been iterating on humanoid models at a pace that has produced multiple generations of increasingly capable robots within timelines that Western competitors have struggled to match. Agibot, another Chinese humanoid robotics company, has been developing humanoid robots specifically focused on practical commercial deployment in manufacturing, logistics, and service applications. Agibot has demonstrated robots capable of complex bimanual manipulation tasks, using two hands together for coordinated work, at a level of dexterity that represents a genuine technical achievement. Fourier Intelligence, based in Shanghai, has been developing humanoid robots with a focus on rehabilitation and assistive applications, but the underlying robotics technology is fully transferable to industrial and commercial deployment. Fourier's GR series of humanoid robots has demonstrated impressive capability across a range of practical tasks. Xpeng, better known internationally as an electric vehicle manufacturer, has been investing significantly in humanoid robotics as part of its broader vision of integrated mobility and automation. The cross-pollination between Xpeng's automotive AI systems and its robotics development creates a deep technological foundation that pure robotics startups cannot easily replicate. Beyond these four major players, there are dozens of smaller Chinese humanoid robotics companies, many of them spinning out of major Chinese universities, others backed by the major Chinese technology giants like Tencent, Alibaba, and Baidu, that collectively form an ecosystem with a density and momentum that no other country can currently match. The supporting infrastructure is equally important. Chinese manufacturing capability for the precision motors, sensors, batteries, and control electronics that humanoid robots require is the most advanced and most cost-competitive in the world, the result of decades of investment in industrial manufacturing capability that originally served other product categories and is now being redirected toward robotics. Chinese government policy has explicitly identified humanoid robotics as a strategic priority, sector deserving of significant state support regulatory facilitation, and coordinated industrial policy. The scale of what China has built is what makes this story strategically significant. Not one impressive robot from one company. An entire industry, growing at a pace and at a level of integration that no other country has matched. Now let's talk specifically about why this is generating the level of concern it is generating in Washington and beyond. The concerns being raised by the American national security community, by economic policy makers, and by Silicon Valley technology executives cluster around several distinct but related dimensions. The first concern is economic and industrial. Humanoid robots capable of performing complex physical tasks in real-world environments are going to transform manufacturing, logistics, healthcare, and dozens of other industries over the coming decade. The country and the companies that lead in providing these robots are going to capture enormous economic value, both directly from selling the robots themselves and indirectly from the productivity advantages that early adoption of the technology provides. If China dominates the global humanoid robotics market in the way it has come to dominate, the global market for solar panels, electric vehicle batteries, and consumer drones, categories where Chinese companies have established commanding positions that Western competitors have not been able to dislodge, the economic implications for American manufacturing competitiveness over the next 2 decades are significant. Industries that depend on humanoid robots will be importing them from China, training workers to interact with them, integrating them into Western workplaces, and sending revenue, profits, and continued investment back to Chinese companies that will use that capital to extend their technical and competitive lead further. The second concern is technological dependency. Critical infrastructure that depends on Chinese manufactured humanoid robots creates strategic vulnerabilities that did not exist when American workplaces were staffed primarily by human workers. The maintenance and operation of these robots requires software updates, replacement parts, and ongoing technical support that creates an ongoing relationship with the Chinese manufacturers. In scenarios of geopolitical tension or actual conflict, dependence on Chinese manufactured robotic infrastructure could create leverage that the Chinese government could exploit, either through formal sanctions or through more subtle pressure on Chinese companies. The third concern is the manufacturing implications for American industrial base. The same Chinese manufacturing capability that enables affordable humanoid robot production is itself enhanced by humanoid robot deployment, creating a self-reinforcing cycle where Chinese factories using Chinese humanoid robots become more cost competitive against American factories using more expensive labor and less integrated automation, accelerating the relative decline of American manufacturing capacity. The Pentagon and the Department of Commerce have both expressed concerns about the longer-term implications of this dynamic for the American industrial base that is essential to American defense capability. The fourth concern is technological sovereignty and artificial intelligence more broadly. Humanoid robotics is in many ways the integration test for advanced AI capabilities, combining computer vision, natural language processing, reinforcement learning, motion, planning, and real-time decision-making into a single embodied system. Leadership in humanoid robotics is closely connected to leadership in applied AI generally. The same technical talent, the same data infrastructure, and the same computational resources that build advanced humanoid robots also build other advanced AI systems with applications across every sector of the economy and every dimension of national power. Now let's talk specifically about the manufacturing and cost advantage that has put Chinese humanoid robotics companies in such a strong competitive position, because this is the dimension of Chinese capability that American companies are finding hardest to overcome. Chinese humanoid robots are being produced and sold at price points that are dramatically lower than what American competitors can currently achieve. The Unitree G1 starts at price points that are a fraction of what Boston Dynamics charges for its Atlas robot or what Tesla projects for Optimus pricing once Optimus reaches commercial release. Agibot, Fourier, and other Chinese manufacturers are operating in similar price ranges that make their products accessible to a vastly larger market of potential commercial customers. This price advantage is not the result of cutting corners on capability. The Chinese robots are not significantly less capable than their American competitors at the price points that matter. They are achieving competitive capability at dramatically lower prices because of structural advantages in their manufacturing base. The first structural advantage is access to a deeply integrated supply chain for the critical components of humanoid robots. Servo motors, precision actuators, sensors, batteries, processors, and the dozens of other specialized components that go into a humanoid robot are all manufactured at scale in China, often by suppliers within short driving distance of the robotics companies that assemble them. Chinese humanoid robotics companies can iterate on hardware design, source replacement components, and respond to manufacturing issues at a speed that American competitors operating with longer and more dispersed supply chains cannot match. The second structural advantage is manufacturing scale and process maturity. Chinese factories have been producing high-precision electronics, motors, and mechanical systems in massive volumes for decades. The processes, the workforce skills, the quality control, systems, and the production capacity that enables this manufacturing have been continuously refined over years of operation. New robotics products entering production at Chinese factories benefit from this entire accumulated capability rather than having to build it from scratch. The third structural advantage is labor cost dynamics that, while less significant than they once were, still favor Chinese manufacturing for products with the labor intensity of current generation humanoid robot assembly. The combination of skilled technical labor at lower wage rates than equivalent American or European labor, particularly for engineering, prototyping, and assembly work, provides a real cost advantage that is difficult for American companies to neutralize without their own equivalent manufacturing scale. The fourth structural advantage is Chinese government industrial policy support, state backing in various forms, direct investment, preferential lending, regulatory facilitation, support for international market access, reduces the cost of capital and the cost of growth for Chinese humanoid robotics companies in ways that American venture-funded competitors cannot match without similar government support. These structural advantages create a cost gap between Chinese and American humanoid robots that is not going to close through American companies trying harder. Closing the cost gap requires structural responses, rebuilding American manufacturing capability, restructuring supply chains, and making strategic investments in the industrial base that take many years to come to fruition. Now let's talk honestly about the military dimension of this, because this is the part of the story that the Pentagon has been most focused on and that the public conversation has covered least. Humanoid robotics is what the defense community calls a dual-use technology, a category of technology with significant applications in both civilian, commercial contexts and military contexts. The same humanoid robot platform that performs warehouse logistics tasks in a commercial setting could, with software modification and hardware adaptation, perform military logistics tasks in a combat environment. The same dexterity, mobility, and decision-making capability that makes a humanoid robot valuable for assembly line work, makes it valuable for explosive ordnance disposal, for casualty evacuation, for reconnaissance in dangerous environments, or for any of the dozens of military functions, where placing a robot in danger is preferable to placing a soldier in danger. The Pentagon's specific concerns about Chinese humanoid robotics leadership extend beyond the direct military applications of the robots themselves. The broader concern is about the technology base, the manufacturing capability, and the engineering talent that humanoid robotics development requires, and the fact that all of these resources, once developed and refined in service of commercial humanoid robotics, become available for military robotics applications without significant additional investment. A country that builds an advanced commercial humanoid robotics industry has, as a side effect, built much of the technical foundation for an advanced military robotics industry. The motors are the same. The control systems are the same. The AI software architectures are the same. The talent and the supply chains and the manufacturing capacity all transfer. China's commercial humanoid robotics leadership is, from a defense analysis perspective, also a leading indicator of China's military robotics capability development. American defense officials have publicly stated that they are tracking Chinese humanoid robotics development as a strategic technology priority. Department of Defense investments in American humanoid robotics development through programs at DARPA, through partnerships with American robotics companies, and through Defense Innovation Unit initiatives reflect an explicit response to the perceived competitive challenge from Chinese capability. The same robotics platforms that Boston Dynamics and other American companies are developing for commercial markets are being evaluated for military applications, and the Pentagon is funding development pathways specifically intended to ensure that American military robotics capability is not left behind by the Chinese commercial robotics surge. The export controls on advanced semiconductors that the United States has imposed on China, which have received significant public attention, are partly motivated by humanoid robotics considerations alongside the broader concerns about Chinese AI capability. The advanced processor chips that are needed to run sophisticated AI systems in humanoid robots are among the technology categories that American export controls are designed to limit Chinese access to. Whether these export controls will meaningfully slow Chinese humanoid robotics development is a contested question. China has its own domestic semiconductor industry that has been advancing rapidly, even if it is not yet at the cutting edge of American semiconductor capability. So what is America actually doing about this? And is the response proportional to the challenge? The American response to the Chinese humanoid robotics challenge has multiple components, operating across the private sector and the government. In the private sector, Tesla's Optimus program represents the most ambitious American humanoid robotics effort by a major technology company. Elon Musk has stated that Optimus will eventually be the most important product Tesla ever makes, and Tesla has been investing significant engineering and capital resources into Optimus development. The recent generations of Optimus have shown meaningful capability improvements, and Tesla's manufacturing scale could potentially translate into competitive production costs once Optimus reaches commercial release. Figure AI is another high-profile American humanoid robotics startup that has attracted substantial venture investment and has been developing humanoid robots for commercial deployment in partnership with major industrial companies. Figure has demonstrated impressive technical capability and has secured commercial deployment partnerships that provide both revenue and the real-world testing environment needed to refine the technology. Boston Dynamics continues to operate at the frontier of robotics, engineering capability with humanoid platforms that demonstrate movement capability beyond what most other companies have achieved. Boston Dynamics is now owned by Hyundai, which provides both capital and a potential commercial application pathway in automotive manufacturing. Beyond these high-profile companies, dozens of smaller American humanoid robotics startups are developing in the broader Silicon Valley and Boston technology ecosystems, many of them spinning out of academic robotics research programs at MIT, Stanford, Carnegie Mellon, and other leading universities. In the government, federal investment in robotics research and development has increased significantly in response to the Chinese competitive challenge. DARPA continues to fund advanced robotics research that pushes the boundaries of capability. The Department of Commerce has identified robotics as a strategic technology priority. The CHIPS Act and related industrial policy legislation includes provisions intended to strengthen the manufacturing base that supports robotics production. The honest assessment of these efforts is that they are substantial but face the structural disadvantages that the Chinese ecosystem does not face. American humanoid robotics companies are operating without an integrated manufacturing supply chain at the scale that Chinese competitors enjoy. American venture funding, while plentiful by global standards, does not match the combination of private investment and state backing that Chinese competitors receive. American manufacturing capacity for the components humanoid robots require has been hollowed out by decades of outsourcing that will take significant time and investment to reverse. This is not a race that America can win by trying harder in the short term. It is a race that requires sustained, multi-year structural investments in the American industrial base, in domestic manufacturing capacity, in supply chain resilience, and in the development of competitive cost structures for advanced robotics production. Those investments are beginning to happen, but they will take a decade or more to fully bear fruit. So who actually wins the humanoid robotics race, and what does the next 5 years realistically look like? The honest answer is that the global humanoid robotics race in 2026 is not a single race with a single winner. It is multiple parallel competitions across different market segments, geographic regions, and technology dimensions. And the picture in 2031 will likely be a mix of Chinese dominance in some segments, American leadership in others, and significant competition in the rest. In the commercial mass market for industrial and logistics, humanoid robots, the segment where price competitiveness, manufacturing scale, and supply chain depth matter most, China is positioned to dominate over the next 5 years. Chinese manufacturers will likely capture the largest share of global commercial humanoid robot deployments because their cost structures and production capacity make them the economically rational choice for most commercial customers. In the premium high-capability segment, the segment where engineering sophistication, and capability ceiling matter more than price. American companies like Boston Dynamics and the most advanced offerings from Tesla and Figure may maintain meaningful positions, supplying customers who need the highest capability robots and can afford to pay for them. In military and defense robotics applications, where Chinese products will be excluded from Western markets on national security grounds, American humanoid robotics companies will likely dominate Western defense procurement and will be supported by federal investment that ensures the American capability gap with China does not become strategically dangerous. In the consumer and domestic humanoid robotics market, which is still nascent but represents potentially the largest long-term market, the competition is genuinely open and will depend on which manufacturers can solve the safety, reliability, and cost challenges of putting humanoid robots into homes at scale. Both Chinese and American companies are actively pursuing this market, and the winners will be determined by factors that are difficult to predict from current information. The 5-year outlook is not American victory or American defeat. It is a future in which the global humanoid robotics industry has multiple major players from multiple countries, in which Chinese leadership in the mass market reshapes economic dynamics across many sectors, in which American leadership in premium and defense segments preserves significant capability, and in which the strategic competition between American and Chinese humanoid robotics ecosystems continues to drive innovation and concern in roughly equal measure. What is certain is that humanoid robotics is going to be one of the defining technology stories of the next decade. The countries and companies that lead this race will shape the global economy, the future of manufacturing, the nature of work, and the strategic balance between major powers for generations to come. And that is the full story of why China's humanoid robotics industry is worrying the United States, what the specific dimensions of the Chinese advantage actually are, what America is doing in response, and what the next 5 years of this critical technology race look like. This is one of those stories that does not get the mainstream coverage it deserves because it does not fit neatly into the news cycle of any given week. But it is one of the most important technology and strategic stories of our time, and the people who understand what is happening here will be better positioned for everything that comes next. Now I want to hear from you. Do you think America can actually catch up to China in humanoid robotics, or has the gap already become too large to close? Drop your honest assessment in the comments below. I read every single one, and this is exactly the kind of strategic question this community discusses better than anywhere else. If this video gave you a clearer understanding of a story that most people are getting only fragments of, hit the like button right now. It genuinely helps this channel reach more people who need to be paying attention to these developments. And if you are not subscribed yet, join this community right now and turn on the bell notification. Every single week we cover the technology stories that matter, told seriously, told completely, and told before the mainstream conversation catches up. I will see you in the next one.